Hello viewers, welcome to my channel Chemphilic. I am Dr. Mala Das Sharma, a retired professor of St. Pius 10th Degree and PG College for Women, Hyderabad. In this video number 12, I am going to teach a topic from carbohydrate chapter by adopting a self-designed innovative teaching methodology, teaching chemistry through riddles. Hope students will enjoy. Here is riddle number 12. Mr. X is a chemical reagent capable of producing shining mirror with many compounds. Mr. Y is one such compound that can produce shining mirror with Mr. X. Mr. Y is also familiar to all because it can provide instant energy. He is optically active and exists in two forms with different specific rotation values. So, this is riddle number 12. Now, let's see the questions. Question number 1. Who is Mr. X? This is the primary question. The other questions are number 2. Who is Mr. Y? Number 3. Why Mr. X produces shining mirror in combination with Mr. Y? What is the chemical composition of the shining mirror? Number 4. What are the two forms of Mr. Y? So these are the questions. Now, this for the answer of primary question. The primary question is, who is Mr. X? And the answer is ammonical silver nitrate solution or Tollens reagent. This riddle is framed to explain anomers and mutarotation of glucose. The molecular formula of glucose is C6H12O6. There are some reactions which can explain the following open chain structure of glucose. I am going to explain all the reactions. Now just assume that this is the open chain structure of glucose where one aldehyde group at one of the terminal positions and there are 4 chiral carbon atoms. Let's justify this structure with the reactions of glucose. Now, glucose forms oxime and cyanohydrin derivatives. See, carbonyl compounds, that means aldehyde and ketones, they react with derivatives of ammonia like hydroxylamine, hydrazine, etc. and undergo a condensation reaction whereby a molecule of water is removed. Now, the oxygen atom of the carbonyl group and this 2 hydrogen atom, this is hydroxylamine, this 2 hydrogen atom is removed as water. And then the remaining part of this reagent, that is hydroxylamine, is attached with the carbonyl carbon atom by double bond. So, here CH, then double bond NOH. Now, carbonyl compound, that is aldehydes and ketones, they undergo an addition reaction with hydrogen cyanide. This is nucleophilic addition reaction whereby the nucleophile cyanide, it attacks the carbonyl carbon atom and then finally this addition product is formed. Okay, where this carbonyl carbon atom gets attached to cyano group, OH group and 1 hydrogen and the remaining part. So, glucose forms this oxime derivative and cyanohydrin derivative. Now, glucose on oxidation with bromine water gives gluconic acid and gluconic acid contains same number of carbon atoms like glucose. In glucose also there are 6 carbon atoms. Gluconic acid also there are 6 carbon atoms. That means the carbonyl group present in glucose, that is aldehyde group, because the aldehydes on oxidation produces acid with same number of carbon atoms. Ketones on oxidation gives acid with less number of carbon atoms. So this proves that the aldehyde group is present in glucose molecule. So oxidation with bromine water gives gluconic acid having the same number of carbon atoms. The presence of aldehyde group can justify the above reactions. That is all the reaction. That is oxime derivative, cyanohydrin derivative, formation of gluconic acid, etc. Now, glucose, when treated with acetic anhydride, it forms pentaacetate derivative. Acetic anhydride is an acylating agent. The compounds having OH group or amino group, when treated with acetic anhydride or acid chloride, the hydrogen atom is replaced by acetyl group, that is CH3CO group. Here also these hydrogen atoms are replaced by CH3CO group. So CHO, CO, CH3. Okay, and it is giving the pentaacetate derivatives. Who is giving? Glucose. That means the glucose has 5 OH groups in its structure. The glucose forms pentaacetate derivative with acetic anhydride. This reaction supports the presence of 5 OH groups in glucose molecule. These 5 OH group, they may attach to the different carbon atom, that means 5 different carbon atoms, or it may happen that 2 OH groups are attached to one carbon atom. But if 2 OH groups are attached to a particular carbon atom, then easily dehydration reaction occurs. That means water is removed. But glucose does not undergo dehydration easily. That proves that all these 5 OH groups are attached with 5 different carbon atoms. Glucose does not undergo dehydration easily. This proves that 5 OH groups are attached to 5 different carbon atoms in glucose molecule. Now, when glucose is reduced with hydrogen iodide, the product is N-hexane. And N-hexane, a normal hexane molecule, all 6 carbon atoms are in same straight chain. That means in glucose also all 6 molecules are in a same straight chain. So on reduction, glucose gives N-hexane. It can be concluded that all 6 carbon atoms of glucose are in same straight chain. So all these reactions which I explained, that all those reactions supports the open chain structure of glucose. But this open chain structure of glucose suffers from the following limitations. Let's see. D plus glucose does not give Schiff's test and does not form bisulfite adduct. Schiff's test is the test for aldehyde group. Though aldehyde group is present in glucose molecule, it does not respond to Schiff's test. And carbonyl compound, they undergo a nucleophilic addition reaction with bisulfite, that is on treatment with sodium bisulfite. Glucose has CHO group, that is aldehyde group, but it does not form bisulfite addition product. That means that open chain structure of glucose cannot explain this phenomena. Now, D plus glucose exists in 2 isomeric forms. One is alpha form and second one beta form. Melting point of alpha form is 146 degree centigrade and specific rotation value is 112 degree in fresh aqueous solution. Whereas melting point of beta form is 150 degree centigrade and specific rotation is plus 19 degree. Now, the specific rotation of an aqueous solution of alpha D plus glucose falls from plus 112 degree to plus 52.7 degree. That means, if you take the aqueous solution of alpha D plus glucose, initially you will find that specific rotation value is 112 degree. But with time, the specific rotation value will decrease and finally it becomes stable at 52.7 degree. Whereas specific rotation of beta D plus glucose rises from 19 degree to 52.7 degree. That means if you take aqueous solution of beta D plus glucose, initially specific rotation value will be 19 degree, but slowly it will increase and finally it will become stable at 52.7 degree. Thus, alpha and beta forms of glucose gives an equilibrium mixture with a constant specific rotation value. We'll see. So, whether you take alpha D plus glucose or beta D plus glucose, finally it forms an equilibrium mixture. So, their specific rotation value changes and finally they attain, both the isomer attains that specific rotation value of plus 52.7 degree. Such a change in specific rotation of each isomeric form to the equilibrium value is called mutarotation. That means the phenomena of change of specific rotation value of one isomeric form to the equilibrium value is known as mutarotation. Now, before going to the other reaction, let me tell you the hemiacetal and acetal formation of carbonyl compounds. When carbonyl compound is treated with alcohol in presence of dry HCl, anhydrous HCl, then first it forms this hemiacetal where one alkoxide group is attached with the carbon atom, and finally on reaction with another molecule of alcohol it forms the acetal. So acetal formation is not a direct reaction, it comes through hemiacetal formation. Remember this point. Now, when glucose is treated with this methyl alcohol in presence of anhydrous hydrochloric acid, then it forms that methyl alpha D glucosides and methyl beta D glucosides, and the characteristics of glucosides are similar to that of acetal, not hemiacetal. That means already the hemiacetal structure must be present in the glucose molecule. So, treatment of D plus glucose with methyl alcohol and anhydrous hydrochloric acid gives methyl D glucoside, which exists in two forms, methyl alpha D glucoside and methyl beta D glucoside. The chemical behavior of glucosides are similar to acetal. Hence, glucose exists in hemiacetal form. Now, to explain this fact that glucose exists in hemiacetal form, a cyclic structure of glucose where that formation of an intramolecular hemiacetal is taken place by reaction between the aldehyde group and OH group of the fifth carbon atom was proposed. Okay? And this generates a new chiral center at C1 which can give two possible structures. Such a pair of diastereoisomers which differ only in the configuration of C1 are known as anomers, and the carbon C1 is known as anomeric carbon. See, in the open chain structure of glucose, there are 4 chiral carbon atoms, 4 asymmetric centra. But once this cyclic structure is formed, which is nothing but the hemiacetal formation between this aldehyde group and the OH group of 5th carbon atom, then one more chiral center is produced. Okay, that is at the C1 or first carbon atom. When one more chiral center is produced, that means this structure can present in the 2 isomeric forms depending on the configuration of this C1 carbon. So, this is the alpha B plus glucose where the configuration at C1 carbon is like this, OH group on the right hand side, hydrogen left hand side. This is beta D plus glucose where the configuration is OH group in the left hand side, hydrogen right hand side. So, alpha D plus glucose and beta D plus glucose, they differ only at the configuration of C1 carbon atoms. That's why they are anomers. Now coming to the answers of the other question. Question number 2. Who is Mr. Y? Answer is D plus glucose. Already you know it. Number 3. Why Mr. X produces shining mirror in combination with Mr. Y? What is the chemical composition of this shining mirror? So, CH group present in the open chain form of glucose is oxidized by the mild oxidizing agent like Tollens reagent to gluconic acid, and then the silver ion of this Tollens reagent is reduced to silver, metallic silver. That means the chemical composition of the shining mirror is metallic silver, deposition of metallic silver. Number 4. What are the 2 forms of Mr. Y? One form is alpha D plus glucose and the second form is beta D plus glucose. Please write your comments about this video in the comment box. Link of my previous videos on teaching chemistry through riddles is given in the description box. Watch those videos if you are yet to watch them. Thank you.